Hello everyone, we're going to look at this question from 2006 Specialist Maths Exam 1. Question 1, we have some relation in terms of x and y, and we have to find an expression for the derivative dy dx in terms of x and y. Now this is a process called implicit differentiation, and two important things we have to employ when differentiating such a relation is first drawing on this idea. We're using the chain rule, where if we differentiate a function of y, well, first we got to differentiate that function of y with respect to y and then multiply by dy dx, which really is just our y dash. And the other thing we need to draw on is the derivative of two functions in a product like that. One might be a function of x and one might be a function of y. So in using the product rule, okay, we get an expression like this, where on the second part, when we differentiate the function of y with respect to x, we're going to use our chain rule part again. So we've got this part there that included in the chain rule expression. Okay, so let's see how that works. So first off, we want to differentiate both sides of the expression. Now that's essentially what you would do in an algebraic sense, where fortunately the derivative of 0 on the right hand side is still just 0. Now when we differentiate the left hand side, the first bit here is in fact a product of two functions. So let's differentiate x, gives you 1 times y, plus we've got our 2y, and then we differentiate y, which is dy dx, our y dash, minus. Now here, the next term, we're differentiating first with respect to y. So differentiate y squared gives you 2y, but we have to multiply by our dy dx, our y dash at the end. So it's equivalent using the chain rule. Okay, and then the last one is this one here, derivative of 9 is just 0. Okay, so far so good. Then we are simplifying it a bit to give that expression, and then we have to transpose for y dash. So we subtract our 2y term to the other side to get that. Then we've got a common factor of y dash in each of these terms. So factorize y dash out, and then lastly we have to divide by our bracket to get y dash by itself. Okay, gives us this. And cancelling out some common factors, and we get that as a simple expression for the derivative, and this you can see in terms of y and x. Part B, hence find the exact value of dy dx at y equals 1. Now if you have a look at our derivative there, it's in terms of y and x. So when y equals 1, we can substitute 1 there and a substitute 1 there, but we don't have an x value yet. We need to work out what x is for when y is 1. So that's the first bit we have to do. We take the original relationship up top here, and we go ahead and sub in y equals 1, and we solve for x, and we get a value, x value of 0. So there we go, there's our corresponding x value. And we sub both x equals 0 and y equals 1 into our derivative, and we get 1/9 for 2 marks. Okay,